this video we're going to take a look at calculating the area of a sector of a circle, the area of a triangle, and the area of the segments as a result. So the first thing is they're asking us to do here is to derive a formula in terms of r and theta radians for the area of the minor segment. So the minor segment down here is the part labelled in brown or orange, and they want us to figure out what that is. Now, first thing I'm going to do is I'm going to draw out where that is. So it's actually part of a sector. It's like a slice of the circle. So that minor segment belongs to a sector of angle theta, and the radius is just r for now. What I also notice is that within that sector there is a triangle. So if I look here, there's a triangle, and that triangle actually cuts the segment off where we want it. So I'm actually also going to draw out that segment, or that triangle, so I can see where the segment is. So the triangle is also of angle theta, because I'm just taking it out of the exact same shape. That's a length r, that's a length r. And what I can see is that if I want that orange section, and that orange section on its own, I'm going to get my sector, and I'm actually going to cut out or take out or cut away the triangle. So the triangle goes like this, and look what's left over. If I subtract the blue, if that blue was cutting away from the sector, I'm left with the orange region which we were looking for. So that's our goal. So in order to do that, we have to first find the area of the sector and then find the area of the triangle. So the first thing I'm going to do is say that the area is equal to a half r squared theta. How do I know that's the right one to pick? In the log tables, there's two of them. For the area of a sector, you have to take a look at what your angle is reported as. Is it recorded in terms of radians, or is it recorded in terms of degrees? And if it's reported in terms of radians, this is the formula you need to take. If it's degrees, it's pi r squared times theta over 360. This is the area of our segment. I don't need to use the information of the second part yet, because they still just want the formula reported in terms of theta. The next thing then is our triangle. Now, it's a non-right angle triangle, and how do we find the area of a non-right angle triangle? It's going to be a half AB sine of C. So that's in your log tables. How do I know to use it? Well, it's non-right angle triangle, and I have the two sides, they're r and r, and I have an angle that is created by the two sides, r and r. So I'm going to have a half r squared sine of theta. So that's the area of our triangle. What we said we were going to have to do was get our area of our segment, or our sector, take away the area of the triangle, and we'd be left with the area of our segment, which I'm going to call AO for the orange or brown, whatever you want to call it. So the area of the orange is equal to the sector, which is the pink formula, minus the area of the triangle. So let's set that up. So underneath I'm going to write a half r squared theta minus then a half r squared sine of theta. And why is it r squared? I'll just go back a step. The formula here came from a half a, which is the side, times b, which is the other side, times sine of the angle created by those two sides. And r times r gives you r squared. So that's where that came from. So now I'm trying to get those subtracted from each other. They don't subtract nicely from each other. It's not incorrect to leave it like that, but in maths we like to write things as neatly as we possibly can, and I can see that between these two things we have a common factor. So there is a common factor between these, and it is a half r squared. So I'm going to write then a half r squared outside of the bracket, and then inside of the bracket I'm going to have theta minus sine of theta, because that's what's left over if I factorize out my half r squared, which was common to both. And that there is the complete formula for the area of the minor segment that they were looking for. That is how I would calculate it if I had r and I had a value for theta. Now, the second part of the question gives us a value for theta, but it asks us then to calculate the area of the major segment and get that as a ratio to the minor segment. Now, the major segment is going to be all of the white. So I made this mistake the first time I did this question in assuming it was just the this section around here. It's actually all of the remaining part of the circle. So easiest thing I can do first is continue with what I had, which is the minor segment. I can fill in my angle there. So I'm going to start with that because it's nice and easy, and you always want to be thinking, okay, what's the bare minimum I can do here to pick up some marks straight away? And then you can start to get into the heavy thinking. But always start out with, what do I know? What can I write down that's definitely going to get me marks? So what I know can get me marks here is I can write out this, but instead of having theta, I can fill in what I actually know it to be, which in the question they've told us is pi over 2. So this here is coming from the question. Now, when I go to simplify that, I actually know that sine of pi over 2 is actually 1. So I'm going to take this out and I'm going to write it as 1. So it's going to be taken out and I'm going to replace it with the number 1. That can't really be written any simpler. You could write it as 1 fraction if you liked, but I'm going to leave it like that for the time being. Now I'm going to work on the major segment, which was basically everything else that remained. So the major segment. Now, it seems like a horrible job to be able to find out what all of that white section left behind is, but it really is actually just the full area of the circle, which would be pi r squared, take away the minor segment. Just take out that little section at the end. That's all. So the area of the MS, I'm going to call it major segment, is equal to, we said the full circle, pi r squared, take away our minor segment, which worked out to be a half r squared pi over 2 minus 1. And if I go to tidy that out or multiply things out, what I'm going to get then is a half r squared minus, multiplying this out, r squared over 4 times pi, don't forget the pi, and then plus a half r squared, or r squared over 2. If I tidy that up further, I can actually group these, and what I'm going to get is this take away this. Right, how am I going to do that if this is a fraction? I'm going to write this as a fraction. This is one whole thing, and this is a quarter of that whole thing. So I'm going to actually make this 4 quarters. I'm allowed to do that so long as I keep it having the same value overall. It's going to be 4 quarters and it's take away 1 quarter. So then I'm left with 3 pi r squared over 4. And then I'm going to have plus, I'm going to change this one to r squared over 2. So that's that. So that's our major segment, sorry. So our major segment. Now we're just being asked to compare this to this one. So we're looking to get a comparison of the two. What might help us is I'm going to factorize out again r squared over 2, or a half r squared like we have up here, because it might just speed it up a lot when we get there. That's going to be left with 3 pi over 2 plus 1. So it's going to speed up the next step, because this then I'm going to take down here. This was the major segment. I'm going to say that compared to our minor segment, which we worked out earlier on. And you'll see now why I factorized out the half and the r squared. So this could actually be written as r squared over 2. So that's r squared over 2. I'm going to divide both sides by r squared over 2. I'm allowed to do that. And then I have 3 pi over 2 plus 1 is to pi over 2 minus 1. So what I'm going to do is multiply both sides by 2 here. So I'm going to get 3 pi plus 2 is to pi minus 2. And that's actually as far as we can simplify it. That's our answer. So it takes a while to break down, but all of the steps are very doable. And it is just about breaking it down into small bite-sized pieces. What can I do? What can I say? And writing down your formula, drawing sketches, seeing how they all connect, asking yourself, okay, the major segment, what does that look like? And describing it in words to yourself. That's what you need to do with these questions. Not getting overwhelmed with, I don't know where I'm going with this at the end. What's the answer going to look like? I don't even know what they're asking. There are parts to the question you can immediately start writing down, like your formula and subbing in your formula, and it will start to come together when you take it in bite-sized pieces.